In February of 2023, an electronics designer opened an issue on an open-source icon repository. They pointed out a specific problem with the library's resistor symbol. It used the squiggly line instead of the international norm defined by IEC 60617. This request highlights a persistent fracture in how electrical engineers document hardware. North American engineering education often defaults to legacy regional symbols, while the rest of the world has adopted a strict, formalized international standard. If you studied electronics in the United States, you likely learned the IEEE and ANSI conventions. You draw resistors as jagged, zigzag lines, and you use uniquely curved, distinctive shapes for AND and OR logic gates. Under the IEC 60617 standard used globally, those unique shapes disappear. Resistors, logic gates, and integrated circuits are all rendered as uniform, rectangular blocks. This creates immediate friction for engineers collaborating across borders. A schematic drawn in California can look entirely alien to a manufacturing facility in Shenzhen or a design team in Stuttgart, requiring mental translation to parse the logic. This discrepancy stems from a systemic push by IEC Technical Committee 3 to convert human-drafted art into machine-readable data. The International Electrotechnical Commission's Technical Committee 3, or TC3, governs the standardization of graphical symbols and technical information representation. Their primary objective is to phase out the historical practice of treating schematics as standalone artistic drawings intended solely for human eyes. Modern hardware design relies on electronic design automation software, enterprise resource planning systems, and automated manufacturing pipelines. These systems require structured, machine-sensible ontologies to verify connections, track inventory, and program assembly robots. A symbol optimized entirely for rapid human visual recognition, like a jagged resistor, becomes a severe liability in this environment. Complex, irregular geometry is computationally heavier to render and harder to map into a rigid, uniform database architecture. To see why this shift occurred, look at the history of logic gates. The familiar curved shapes were formalized by a 1960 AIEE and ASME task group, eventually becoming the U.S. Air Force's MIL-STE 806. This standard codified the exact geometry of the distinctive shield shapes we associate with AND and OR logic gates. A highly effective, human-centric design. A draftsman could draw them by hand, and engineers could instantly trace logic flows by recognizing their distinct exterior silhouettes. As digital logic grew exponentially more complex through the 1970s, custom shapes reached their operational limit. Designing a unique silhouette for every new, highly specialized integrated circuit became impossible. The industry began migrating away from the ANSI Y32.14 standard that maintained these shapes, seeking a more systematic approach. The solution was the IEC 60617 mandate, which forced all logic gates into a standardized rectangular block footprint.